So this is chapter 6-1, Graphing Systems of Equations. We're going to start with definitions. Make sure that you're still taking notes along with the video so that you can have these to look back on. So the first definition, this is the most important definition, is system of equations. This word right here, we're going to be using it a lot for this whole chapter, so it's really important to understand what it means when we say system of equations. A very general way to describe this is just when you have two or more equations, and in this case today we're going to be graphing it, but it means two or more equations either like written down in a problem. It could be any type of equation. It could be linear, quadratic, exponential, just when you have multiple equations. And in particular, a lot of the problems that we're going to be solving will ask you to find the solution or the answer to a system of equations. And when they are asking for a solution, what they mean by this word is that when you have two equations, either graphed or on the page, a solution is where both of them will share the same x and y values. So the solution to a system of equations is where both equations, or if you have more than two equations, all of the equations, so when both of the equations share the same x and y values. So it could be one x and y value, or it could be multiple x and y values. We will take a look at this in just a second. So again, we want to focus specifically on the fact that we're just going to be looking at multiple equations, and we are going to be finding the solution. And the solution just means when both of our equations have the same x and y. So I said earlier that you could have one x and y value that they share in common, or you could have multiple. So I'm going to show you visually what this looks like on a graph when we are talking about how many solutions, or what are the solutions to our system of equations. So I'm going to be using two colors here to represent two different lines or two different equations. So line number one, we are going to use red. I'm just going to sketch a picture right here so that we can visualize it. It doesn't need to be perfect. So this is line one, right here. I am also going to sketch my second equation, or my second line, in blue, right here. This is line 2. So obviously this is just a rough sketch, but you can see that both of these lines are on the same graph. This would be called a system of equations, and these are actually parallel to each other. So they're both straight lines. They do not touch, and they will keep going on forever. They will never touch. When this happens, and you are asked how many solutions does this system have, you would say no solutions, or zero solutions. Why? Because in order to have a solution, they need to share, this goes back to our definition, share the same x and y values. If your lines never cross, that means they're not sharing any x and y values in common, so we would have no solutions. So when you have no solution, it's either, you can think of it as your lines never cross. Okay, they share no x and y values in common. So this would be an example of a system that has no solutions when it is parallel like this. Let's take a look at our second example right here. Let's say line 1 looks like this. Now I kind of reversed the colors here. That's fine. Okay, so red will be line 1 again, blue will be line 2. Okay, so now it looks a little bit different. You can see now they are crossing each other. When they cross like this, I'm going to put a dot right here at the point where they cross. This spot right here is a solution, because at this exact spot, they share this point in common with each other. The blue line has this point somewhere on the line, and this red line has this dot somewhere on the line. So they're sharing an x and y value. So in this case, we would have one solution, because there's only one spot where they share this point. You can think about this as where they cross, where the lines cross. Okay, where they cross is that x and y value they share in common. So they share one xy coordinate in common. And so we would have a solution right here for these two lines. All right, the very last example here is we could have a case where if this was line 1 and this was line 2, notice how I'm drawing them right on top of each other? That is intentional, because these lines are stacked right on top of each other. They are the same line, but we graphed it multiple times. So technically, there are multiple equations here. So because they're stacked right on top of each other, that means that they are sharing every single point in common with each other. Right? They're sharing all of the points. If they are sharing all of the points in common, that means that there are infinite solutions. So many that we can't even count, because every single point is in common. So either they are, you can think about it as overlapping, or you can also think of it as just they share all the points together. So they share all of the same x and y values. Or in common. So with lines, straight lines like this, we only really have 3 scenarios. Either no solution, because they never touch each other, one solution, because they cross, or infinite if they are right on top of each other, if they're the same line. So let's say you got a problem that looked like this. It asks you how many solutions, or what is the solution, for the system of equations. We have an equation here, y equals 3x minus 4, and then we have our second equation, y equals negative 2x plus 1. So using the graphing method, we're going to learn a lot of different methods, but using the graph, we can determine how many solutions or what the solution is. To do this, I'm going to use Desmos to demonstrate one way. So using Desmos, we can graph lines by typing in the equation. So I'm going to type in the first one, y equals 3x minus 4. Okay, you can see it's this red line right here. And then I can type in the other equation that they gave us, y equals negative 2x plus 1. And when I type that in, it's nice, they give you separate colors so you can see which one is which. And if we look at this picture right here, it looks like a lot like the one that we took notes on, where they intersect one time, right here. And you can see when you're on the computer and you hover over this point where they are crossing, it will actually tell you what the coordinate value for this is. So for this one, when we plot them, we have 1, negative 1. So going back to this problem, if I were to describe what I saw on the graph, the first thing they wanted to know was how many solutions. How many times did the lines cross? They crossed once, so there is one solution. And they also need to know what is the solution. The solution is that coordinate point where they crossed. In this case, the solution was 1, negative 1. That was where they crossed. And the Desmos actually allows us to see that right here, 1, negative 1. So that is how we can use graphs to find the. Let's say we get a different type of problem, like this one on Delta Math. It wants us to solve this system of equations, and they give us the equations like this, but we have to plot it ourselves now. So doing this, we want to go back and review, remember how we plot linear equations. But as a quick review, let's plot the first one, y equals x plus 6. So this number right here that we're adding is the y-intercept, so I need to first plot the y-intercept, and then I need to look at the equation and figure out what the slope is. The number that is in front of this x is a positive 1. It is invisible, but there's a positive 1 always. So that means I have a rise of 1 and a run of 1. So slope is always rise over run, so I go up 1 and then to the right 1, and that will be my first equation, x plus 6. Second equation, I do the same thing. This time I have a y-intercept of negative 2, put a dot here, and then the slope is negative 3 over 5. So my rise is negative 3, so I go down 3 spaces, and then the run is 5, so I go to the right, 1, 2, 3, 4, 5, and I plot it there. If you need to review graphing, go ahead and check out some of the previous videos to remind yourself how to graph these equations on your own. But once we do that, we can see that they cross one time. So there's one solution here. They want to know what the solution is, so you need to read the graph carefully. And this point right here is at negative 5 and positive 1. So when you type in the answer, make sure to use the parentheses around to show that it's a coordinate point, and then you can submit your answer. So now it's your turn to practice. You can do the same thing that we did in this first example and go to Desmos to graph these systems of equations. The first one is y equals 2x minus 2 and y equals negative 1/2 x plus 3. Figure out if there's a solution and what the solution is. And then the second one is y equals negative 3/4 x minus 2 and y equals negative 3/4 x plus 1. So go ahead and graph it. See if you can figure out what the solutions are.